Hi, I'm Stefano Giuffo, Technical Product Manager for Micromine Advance. Since its official release, we've been busy working on several improvements that will take things to the next level. We'll start with an exciting one, an in-house developed Stope optimizer. Every mine plant requires Stope solids for depletion. Mining engineers use parameters and cut-off grades that represents the best possible extraction strategy. However, this process of building these shapes can often be lengthy and complex, requiring significant manual input or shifting between two separate platforms. With our new Stope optimizer, we've streamlined this process, allowing for faster and more efficient Stope shape generation. What sets us apart is that we have an internal team dedicated to continuously shaping and improving the Stope optimizer. The tool follows a simple input list for the users to fill according to the geotechnical and engineering requirements. This tool can be accessed at any point in the workflow. All the user needs to have is a block model, like we have one on the screen, an optimization field, and the parameters. The results are stored in the layers in the design data. So once in the form, the user can select the block model. So in this case, we have this one called Project Set. And then they can select an output layer where all those results are going to go. For example, here I have this layer here. So important thing here is ensuring that we've set up the framework where we're going to be working or doing the optimization on. So one of the key parameters, obviously, we have the tube height, or the stope height, the length, the dip and strike, and if we want to use a control surface or strings to govern that run, like we have in this case, we've selected this particular level strings. So we can also preview this framework, right? So this will allow us to see where those stopes are actually going to fall in the run. So here's just giving me a preview, and it's essentially following those level strings, and this is overriding that height. So another important part here is obviously making sure that we have an optimization field. In this case, I'm not using grade, I'm using a financial value, in this case NSR. So I'll use a cutoff grade of 120 and select some dip and strike parameters as well as the minimum width of those solids, and then we hit apply. So once we have the run, so the results will go into the respective layer, and this process takes only a few minutes. So if I turn off the block model for a second and open up the results that we have for that 80 run, then we can see they are nicely within those strings, which is kind of where we want it to be. That's where our plant levels are. So if we open the block model, you can visualize clearly the results and see really good alignment between the block model and the stopes. Now in the block model, I'm currently using a constraint of 80 as well. So all the blocks I'm displaying have at least 80 NSR. So I'm going to put a cross-sectional view to just quickly see those results in a little bit more detail. So I'm going to select all my solids here, and I'm going to navigate through, and we can see there, the stopes nicely contained within that ore body, and then obviously changing the shapes and the forms as we move through the section, but obviously respecting always the inputs that we've used. So, and again, this is done in only a few minutes. So here we can compare with the second run that I did at 120. So if I select all the solids at 120, we can see the number of shapes are lesser and potentially more narrow. Obviously, this is due to the higher grade that we've picked, and obviously the optimization is following those parameters. Thank you.